So again, the question says solve each one. If I gave this to you, on a test and said solve each equation, you would say, okay, I have the three ways. I can either factor, square root both sides, which I'm just going to write complete the square, or I have my quadratic formula. So you'd have an option for each of those ones. Whether you're using factoring or the quadratic formula, you first have to have it equal to 0. You have to have it in this form, ax squared plus bx plus c equals 0. So even though it looks like it's factored in part A, can you see that it's not equal to 0? So we can't use factoring or part 3, the quadratic formula, yet, because it doesn't look like this form. For completing the square, it doesn't need to look like this, but usually we move this c over to the other side as our first step, or maybe we divide by a before we do that. So it's still not bad to start off by getting everything in this form and then deciding from there what's going to be best. So for a, in order to get it in that form, I'm going to need to expand. So I'm going to need to multiply my first ones, my outside, my inside, and my last. And I would get 2x squared minus 2x plus x minus 1. And on the right side, I still have equals 5x. If I subtract 5x on both sides and combine all my like terms, I will get this. Because minus 2x plus x will give me a minus x. And if I subtract 5x on both sides and combine those, minus x minus 5x will give me minus 6x. At this point, I have a decision to make. Which of those three do I want to do? It doesn't factor, so that one's out of the issue. Often with a number in front, the quadratic formula will be the nicer one. So we'll start with that. So I make a decision. I want to use the quadratic formula. Negative my b value. Label a is 2, b is minus 6, c will be minus 1. Negative b plus or minus b squared minus 4a. Oh, a is 2. C all over 2a. And now we just have to negative negative will be positive 6. 6 squared will be 36 plus 8 over 4. So we're almost done. We just have to see if we can simplify this. Can we simplify the square root? Is there a perfect square we could pull out? 4. 4 times 11. So we got 2 root 11, because square root of 4 is 2. Yes?
Why did you do the 2 times 2 to get the 4?
On the bottom there?
Yeah.
Because in the formula, on the bottom of your formula, negative b plus or minus b squared minus 4ac, it's over 2a. And a is 2. And this would still be all over 4. Now, is there something I can factor out of the top? Yes, there's a 2 in common, leaving me with 3 plus or minus the square root of 11, all over 4. And this would simplify to 1/2. So I'm left with 3 plus or minus the square root of 11, all over 2. So we've written it as a single fraction. Our square root can't be simplified. There's nothing more we can factor out to simplify. This would be our final answer. So a lot of this, the formula works nice, but you still have the algebra part of our chapter 2 where we had to work with our radicals and simplifying fractions and factoring from other years. So for part B here, for part B, if you wanted to make it equal to 0, you subtract 3 on both sides and make it equal to 0. As far as things go here, factoring doesn't look like it would be very much fun with the fractions. Completing the square doesn't look like it would be very much fun with these fractions. So we can start by using the formula. And the formula works even if you have fractions. So I'm going to do it once with fractions, and then I'm going to show you how, if you wanted to, you could get rid of the fractions. Our B value, I'll label them above. A is a half, B is negative 5 over 4, and C is negative 3. So we have negative 5 over 4, plus or minus the square root of b squared minus 4, our a value is a half, our c value is negative 3, all over 2 times a. So it's a little bit nasty in here inside because we have some fractions, but now we can start simplifying it. Negative 5 over 4 will just be 5 over 4. Plus or minus square root of negative 5 over 4 squared will be 25 over 16. Plus, and 4 times a half is 2, times 3 was 6, all over 1, because 2 times a half is 1. We have 5 over 4 plus or minus. If I want to add 25 over 16 plus 6, I'll need a common denominator. So I change 6 times 16 is 96 over 6. I don't have to write over 1 anymore because that's just redundant. Oh, so sorry, 96 over 16. Thank you. To get a common denominator. Because then I could add those fractions together. 25 plus 96 is too big of a number? Oh, isn't this is turning out to be a beautiful number inside. 121 over 16. And this is a nice number because it simplifies perfectly. The square root of 121 is 11. And so we get (11 over 4) because the square root of 16 is 4. Our two answers then, one of them will be 5 over 4 plus 11 over 4, which is 16 over 4, which is one answer is just nicely 4. And the other answer would be 5 over 4 minus 11 over 4, which would be negative 6 over 4, which simplifies nicely to negative 3 over 2. And because our square root simplified nicely and went away, it tells us that our original equation could have been factored. We could have factored this. So what would be the best way to factor this, especially because there's nasty fractions? I would start by getting rid of the fractions. Can you see if I multiplied both sides of this equation by 4? if I multiplied this by 4, this by 4, this by 4, and this by 4, then my fractions would go away. 4 times a half becomes 2. Negative 5 over 4 times 4 just becomes 5. And 3 times 4 is 12. And if I go to factor this, the only possible way would be 2x and x. What are ways to get 12? Three times 4. And if I do 3 and 4, that makes 12. My outside is 8. My inside is 3. Does 8 and 3 ever make 5? Yes, if you're subtracting. So I'm going to make my 8 negative, my 3 positive to get a negative 5. Then when we split it up, x is equal to 4 and x is equal to negative 3 over 2. The same two answers that we got with the formula. But if you can factor, it's faster. So maybe what I would suggest in a question like this with the fractions is once I've got it equal to 0, I'd figure out what I would need to multiply by to get rid of the fractions. And once I've multiplied everything by 4, I got this equation here. Then you could see, can I factor that? And if you can't see that you could factor that, you can now use this as your a value, this as your b value, and this as your c value, and you will get exactly the same answers if you use the quadratic formula with those new numbers. So I did it to show you you can use the fractions if you want to, but had you gotten rid of the fractions, both the quadratic formula and factoring may be nicer. So I'm going to give you your questions here, and then I'll get your question there in a second, Anthony. 7 to 13, all of those ones involve factoring.